Learn how you can use AI to fight the Republic this week on Data Expose MVP Edition, Special Star Wars Edition. Hi, I'm Anna Hoffman, and welcome to this episode of Data Expose MVP Edition, May the 4th Be With You Edition. And this is the fourth or fifth year that we're doing it this way. For that, I have Janobi here with us, who has been here with us for 5 years. So
Yes,
welcome back. Why don't you tell us a little bit about who you are and what you do in the real world or in Star Wars?
sure, you bet. And thank you so much, Princess Anna, for having me back. Like you said, it's been the fourth or fifth year that we've been fighting the good fight against the Republic. I am Janobi Morehouse. I am a principal consultant at Denning Cherry Associates Consulting, where we use the Force to make magic happen with SQL Server and in Azure. So we do a lot of things with data, primarily in the SQL Server space.
Awesome. I love it. And today is no exception to that. So I'll ask you, like, what fight are we fighting today, and how are we going to use Average SQL and SQL Server to do it?
You bet. Great question. As you know, AI is a huge thing in the battle in the world today. And so we want to bring AI to the fight so we can fight the Republic better. So with Azure SQL Database, we've actually got this new tool called vector data types. And we're going to talk about vector data types and how we can use that to help fight the Republic. But before we do that, we have to talk about something called embeddings. So what I have here before you on the slide is just an example. We have the text, the Foundation series by Isaac Asimov, and we can translate that into a series of dimensions or a numeric value data set. So an embedding is basically just that transformation into that number matrix that you see on the right. A good example that I have is here's just a quick example that I wrote in PowerShell because I really struggled with this in terms of what embeddings really were. Uh, and I have an OpenAI um, deployment in Azure. So I'm using the embeddings deployment to actually make that translation for you. But you can see there on line 13, I have this text called My Name is John. And I am basically translating that into an embedding. And we see at the bottom that we get this big list of numbers. That is the embedding. So once we have that embedding, now we can use the new fancy vector data type in Azure SQL.
Awesome. So then, just to wrap real quick, an embedding is just a numerical representation of
Yep.
something else.
Something else. So text, images, that music, audio files. We can make embeddings based off that data source, that data element, if you will,
Makes
for
sense.
sure.
And then, where do vectors come in?
So vectors, we have that's a really big number set, right? So the embedding is a really big number. With using it with OpenAI, that those number sets the computer can use to translate and talk to, right? Because computers all deal with zeros and ones, right? So with the vector data type, we can actually store that matrix of data. So in Azure SQL Database, Microsoft has released a new data type called a vector. It's actually stored as a var binary, but when we query it, it actually comes back as a JSON array. So we actually get an array back based off the individual dimensions or numbers in that matrix. Each element or dimension in the array is a precision 4-byte floating point value. You can have one dimension, or you can have upwards of 1998, so 1,998 dimensions. The more dimensions you have, the more detailed and granular the computer can translate that. So if you probably want more than one dimension, I'm not sure you want to go to 1,998, but you can. So this is just an example in SQL, or T-SQL, the language that we all know and love. We declare a vector data type. In this case, I've done a vector type of 3 in size, which means I've got 3 dimensions. You can see that I've got 1.0, negative 0.2, and 30. Those are my 3 dimensions contained within my vector. Once we have the vector, we can actually do some other stuff with it. And here's a couple different things. Constraints aren't honored. You can't use in-memory optimization tables. You can't alter away from a vector data type, but you can use cast and convert to do other things with it if you wanted to. The real big winner here is vector distance. We actually get some new vector functions where we can do mathematical operations against it. And there's three: vector distance, vector norm, and vector normalize. The big one, though, is vector distance. And that's how we're going to fight the Republic with AI. We're going to use vector distance with cosine to compare the distance between the dimensions in the vector. And the closer that they are, the more similar those data elements are. Okay. So here's a quick example that, whoops. So I have a SQL database. I have a server called Rebellion Alliance. And in my SQL server, I have a database called Rebel Forces. And I've loaded this database with a bunch of data specific to the rebellion. So we've got the different battles we fought, the cities, the different droids we have available to us, different organizations. And I'm really curious about fighting battles on specific planet types. So I have a table called planets. And in there, I have already created some embeddings based off the terrain of that planet. So we can see here that Tatooine is a desert planet. That is the terrain that we have. The vector representation of desert is this numeric embedding. Using the vector function vector distance, let's say we want to find comparable planets that might have bodies of water. We can actually translate this into an embedding live using my OpenAI embedding deployment to get an embedding of this value and then compare it with the vectors that we already have. So let's run this. So I'm going to get that embedding, and then I'm going to use my vector distance cosine and compare those two values. So now I have a list of planets where might have bodies of water. We can see that oceans, I don't even know how to pronounce that planet, but those are planets that have bodies of water. I will point out, though, the line 4 says grasslands and lakes. I'm sorry, number 5, jungles and forests. The trick with this is the number of data elements that you have. So the more data you have, the more closer that the AI can figure out what's better, right? So number 5 showed up because I've only got like 50 rows of planets in the table. If I had 500, I have a better granular result set and I'd have a better answer. But now I have brought AI to the battle. I can now look at my data and all the various battles and planets and starships, and maybe I can start to fight the battle against the Republic in a more concerted effort. So we've brought AI to our data.
I love it. Essentially, you're giving us a way to be more strategic in
Yes.
how we go fight the
Yes.
Republic.
Because now we can use AI and figure out where we want to do our battles. And maybe in the future, we can actually send data to ChatGPT and actually have real live conversations about our data.
I love it. This is awesome. Uh, Genobi, I've learned so much and I'm excited for the battle. I have to ask you any like final tips or tricks or words of advice for folks?
I think that AI, and I think that Microsoft is really smart about pushing AI. I think that as data professionals, we have to pay attention to as to what AI is doing and how we can bring AI to the good fight. So I would advise everybody to start looking and paying attention to what AI is doing.
Awesome. Great. Well, thanks so much.
You bet.
I've learned a lot. I think we're getting ready for battle.
Yes.
I think our viewers probably learned a lot as well. Hopefully, they had as much fun as we did filming this episode. What we'll do is we'll put some links in the description for you to go learn more about this. Maybe check out the sample and leave us a comment and let us know what you think. We'll go ahead and like this episode, and may the fourth be
Fourth be
with
with you.
you. We hope to see you next time on Data Exposed.